we're looking at the Maclaurin series here. This is the formula for the Maclaurin series. It's really the Taylor series, but you calculate it at f of 0, f prime of 0, and so on. The question we want to answer here is, where did this come from? We want to derive the series and see what's the argument behind it. Alright? Now, the Maclaurin series is a power series. And power series generally is in the form f of x is equal to a number times x to the 0 plus another number, call it b, x to the power of 1 plus another number. These numbers are constants, right? See, x to the power of 2 plus some other number, x to the power of 3 plus, and so on and so forth. All right, it's an infinite series, and x is the variable here. X is raised to integral powers, so it's called a power series. All right, now an example of a power series could be the binomial series. It is a power series. Suppose, for example, you have 1 plus x squared, or say cube, 1 plus x cubed. That would be 1 plus x times 1 plus x times 1 plus x. So what you have is 1 times 1, which is 1, 1 times x, 1 plus x times 1, which is x plus x times x, which is x squared. Right? So we completed multiplying the first two brackets. Well, you have 1 times 1, which is 1, 1 times x, which is x, x times 1, which is x, x times x, which is x squared. So this must be multiplied by 1 plus x. So what we have is 1 plus 2x plus x squared times 1 plus x, and then we multiply out 1 times 1, which is 1, plus 1 by x, which is x, plus 2x times 1, which is 2x, plus 2x times x, which is 2x squared, plus x squared times 1, which is x squared, plus x squared times x, which is x cubed, right? So we have 1 plus x plus 2x, which is 3x, plus, then we have 2x squared plus 1x squared, which is 3x squared, plus x cubed. So here we have 1 x to the 0 plus 3 x to the 1 plus 3 x to the 2 plus 1 x to the 3, which is a power series. So we can see our numbers, number times x squared, number by x to the 0 plus number by x to the 1 plus number by x squared plus number by x cubed. This number is 1. So that's an example of a power series. Now, let's look back at this. Suppose we substitute 0 here for x, and we find f of 0. Now remember, this is a x to the 0. So it's really a, because x to the 0, when you multiply a number by 0, you get 1. But if I did not put in the x to the 0 here, what you would have is a plus bx plus cx squared plus dx cubed, and so on. When x is 0, this goes to 0 because b times 0, c times 0 squared is 0, d times 0 cubed is 0. So only a we would have. This is f of 0. Alright? Now, f of 0 is a. So, whatever function we have, we put 0 for x in it and we get a. So we found a. How do you find b? Well, what you could do, if you find f prime of x, you would have this goes to 0 because a constant, and the derivative of a constant is 0. But this now is going to be, remember the power rule, you multiply the power by the function, then you minus 1 from the old power to get the new power. So it's 1 times b x to the 1 minus 0, 1 minus 1 is 0, plus this will be 2c x to the 2 minus 1 is 1, plus 3 dx to the 2. Alright? Let's just add a few more terms here. You would have, after d is e x to the 4 plus f x to the 5 plus g x to the 6 plus, and so on. Alright? So the first derivative, we're continuing it, plus 4e x cubed plus 5f x to the 4th plus 6g x to the 5 plus, and so on and so forth. Alright? You see that? Now, suppose we put in 0 for x and we find f prime of 0. What do we get? Well, 1 times b is b, and this would amount to 1. Alright? X to the 0 is 1. This was 1 times b times 1, because whatever x is, x to the 0 is 1. So we would have just b. So what we have here is b. 0. 2 times c times 0. This is 0. This would be 3 times d times 0 squared, 0. All of these going to the right would be 0. So f prime of 0, alright, is 0. Now, we're ready to find c. What do we do? Well, here, first of all, let's change this and remove the ones. Here now, if we differentiate this, we will get 1 by 2 times c x to the 0, which is 2c. So we could find c. Alright, so f double prime of x equals, when we differentiate b, we get 0. So this is 0. Alright, let's put this here. 1 times 2, 1 by 2 c x to the 0. But x to the 0 is 1. So it's 1 by 2 times c plus 2 times 3, power rule. So this now is 2 times 3 d x to the 2 minus 1 is 1. So it's x to the 1. But we don't have to put the 1 there. Plus 3 by 4. 3 times 4 e x to the 2. You see that? Plus 4 by 5 f x to the 4 minus 1 is 3 plus 5 times 6 g. Remember, it's the power rule we're using. 5 times 6, right, times g x to the 5 minus 1, which is x to the 4 plus, and so on and so forth. So you see that? All right. So we have 2c. Now the first term. Everything else is multiplied by x. So we make x 0. So we're finding f double prime of 0. This is 1 by 2 times c is 2c plus, what happened after this? Everything else is 0. Because 2 by 3 by d times 0 is 0. 3 by 4 by e times 0 squared is 0. 4 by 5 by f times 0 cubed is 0, and so on. So all of these are zeros. So you don't have to worry about the plus part here. You see that? So now, how do we find out what d is? Let's see. Idea. Differentiate again. If we differentiate this will go to 0. And this is x to the 1. When you subtract 1 from 1, you get 0. So it's going to be something x to the 0. And x to the 0 is 1. So let's differentiate again. We find f triple prime of x. This goes to 0. Alright? Then we have 2 times 3 d x to the 1 minus 1, which is x to the 0. But x to the 0 is 1. So you don't have to worry about this part again. No x is here. Plus, this is going to be 2 times 3 times 4 e to the 2 minus 1 is 1. So it's x to the 1. We don't have to show the 1 there. See that? Plus, multiply by the power. This is 3 times 4 times 5 f x to the 3 minus 1 is 2. So it's x squared. Alright? Then out here, what we're going to have is plus, multiply by the power, put the power in front, 4 times 5 times 6 g x to the 4 minus 1, which is 3 plus, and so on and so forth. Alright? Now, if we put 0 for x, this will go to 0, this will go to 0, and so on. This is the only one that will not go to 0. So f triple prime of 0 is, alright, it's 2 times 3d. Now, out here, what you have is 2 by 3 by 4 by e times 0. That will amount to 0. You multiply all of this by 0, you get 0. Same thing will happen here. All of this will multiply 0 squared, and so on. So you're only left with this. Alright? Now, let's see how we can get e. Differentiate again, because this is x to the 1. And when we multiply by the power, and then get the new power by minusing 1, we're going to get x to the 0. And x to the 0 is 1. So let's find f4 prime of x, the fourth derivative. This is a constant, 2 by 3 by d. So that will go to 0. But what happens here? 1 times 2 times 3 times 4 times e. x to the 0. This is going to be 1 plus 2 times 3 times 4 times 5 f x to the 2 minus 1 is 1. We don't need to show it. Plus, what happened out here now? 3 times, we bring down the power, 3 times 4 times 5 times 6 times gx squared plus, and so on and so forth. So you see that. Now, this is what we have. So, suppose we say that we're finding f4 prime of 0. What happened? We'd have 2 by 3 by 4 e, but this part will have 2 by 3 by 4 by 5 f times 0, because this x would be 0. And the same thing would happen to this as well. So here, what we have is f4 prime of 0 is this. All right. Now, we have this so far. We get the idea. But how do we match it up with this? Remember, we say f of x is a x to the 0. What is a? A is f of 0. All right. So here, f of x is equal to a x to the 0, but a is f prime, no, a is f of 0. So we change this a to f of 0. All right. Oh, why I write it like that? F of 0. Now you see the f of 0 here, plus b x to the 1. Let's check that out. Plus b x to the 1. Now, what is b? B is f prime of 0. So if we write here that b is f prime of 0, we get f prime of 0 x f prime of 0. They put the x in front. So let's put the x in front too. So it's x to the 1 f prime of 0. So it's x to the 1 f prime of 0. All right, plus. Now we said we have c x squared. All right. So it's cx squared. Let's put it as x squared c. Now what is c? Now notice we have f double prime of 0 is 2c. So what we do, if we divide both sides by 2, we get c being equal to f double prime of 0 over 2. Alright? So if c is f double prime of 0 over 2. F double prime of 0 over 2. F double prime of 0 over 2. So f double prime of 0 over 2. So let's check this. So it's f double prime of 0 over 2. Alright. So it's x squared f double prime of 0 over 2. Alright. Plus, what happens after this? For the d part, we have 3d x squared. Oh, my, looking at the wrong thing. Is up here. I should look. Dx cube. We have dx cube. So let's write it as x cube d. because we're comparing this with the Maclaurin's series that I had copied, and they put the x to the power on the left. So x cubed d, we want to find out what d is. Alright, so if we transpose this for d, we'd have d equal f triple prime of 0 over 2 by 3. So d is f triple prime of 0 over 2 by 3. F triple prime of 0 over 2 by 3. F triple prime of 0 over 2 by 3. So it's f triple prime of 0 over 2 times 3. Alright. So it's f triple prime of 0 over 2 by 3. Now notice they have it over factorials. So let's match it up with that. 2 by 3 is the same as 1 times 2 by 3. And you know that this, if you remember your factorial, it is 3 factorial. So this is 3 factorial. 2 is 1 by 2. But it's the same as 2 factorial. So we can write it as 2 factorial. So what we have is x cubed f3 prime of 0 over 3 factorial. They have x cubed f3 prime of 0 over 3 factorial. Good. And so on and so forth. We had up to 4 prime, so let's put that in. So we said that the next thing was e x to the 4th. So we have x to the 4th e. But what is e? E, if we transpose for e, would have e equal f4 prime of 0 over 2 times 3 times 4. But 2 by 3 by 4 is the same as 1 times 2 times 3 times 4. So it's really f4 prime of 0 over 4 factorial, right? So that's e, f4 prime of 0 over 4 factorial. So e is f4 prime of 0 over 4 factorial, plus and so on and so forth, right? Alright. Now, here we have 4 factorial, 3 factorial, 2 factorial. So by pattern, this is 1 factorial and this will be 0 factorial. Aha. So there we go. F of 0 plus f plus x, f prime of 0. So we have f of 0 plus x, x, f prime of 0 plus x squared over 2 factorial f double prime of 0, x squared over 2 factorial f double prime of 0 plus x cubed over 3 factorial f triple prime of 0, x cubed over 3 factorial f triple prime of 0, and so on. And they go on. X to the n over n factorial fn prime of 0. So you can see that it goes to x to the n over n factorial fn prime of 0 plus and so on, because it's an infinite series. So there we looked at what the original Maclaurin series is. It's just that we had put in some things that they don't generally show. This amounts to just x alone, you know. To just f of 0 alone, you know. X to the 0 is 1 and 0 factorial is 1. So they generally just put the f of 0, as in this case. Here, 1 factorial is 1. And x to the 1 is x. They generally just put x f prime of 0. Right? x f prime of 0. And then of course the other terms. So that was where we looked at the Maclaurin's series.